Oh, I'm sorry. I think yes. So when I register, I have to send it out when I. Yeah. No, maybe also we can send it again, but maybe. I think so. Yes, there was place for that. Let me have a look. I mean, we can change that. Yeah. So, okay. Can we send an email? Yeah. So.
Yeah, this bill is since many years present at ESOP. It was around. I think Eberhard Regner bought it in the 90s. Yeah, so it's very long with us. Is the time?
Still 3 minutes.
Okay, that's 3 minutes.
Turn on microphone. Okay.
Okay. I see. Do we have somebody who serves the chat and sees?
No.
What do you see? No, do we control the chat? Or? You can see it, yeah. Great. So if any question comes via chat, you will interrupt. Great. It's not possible to see this clock.
The clock has some reflections.
Yeah, it has some reflections.
But maybe we can change the lighting. ¿Puedes cambiar las luces? Bajamos las. Vale. We will drop the shades to avoid reflections.
So I shall start.
Yeah, just 1 minute. So
Yeah,
we
okay.
start.
Yeah, it's okay. I shall be the first speaker. That's my question.
What?
I shall be the first speaker.
Yeah, you're the first speaker. Let's
to.
go. Okay, go ahead.
Yes. Maybe it's better to stand up. Ladies and gentlemen, friends of occultational astronomy, friends here in the room, friends in the world via Zoom and YouTube. Good morning. Very warm welcome to everybody. I have the pleasure to speak some words to you, and what I want to say is thank you 3 times. And the first big thank you to the organizer, to the local organizing committee. Everybody who creates such a symposium know what's to do, what a lot of work is behind the organization. And so we say thank you for the invitation and thank you for the job to organize this symposium. My second thank you is to you. You came from points in Europe, far away, not so far away, I see our friend from Poland, from the border, Poland, White Russia. So it's a long distance. Some people drive with a car half through Europe to be present here as person. A very big thank you to our people here in the room. And Argentina, but not with a car. Yeah, okay, yeah, it's also a long way. So thank you to everybody who is present here in person in the room. And my third thank you goes in the world to everybody who see us now via Zoom, via YouTube, and for these people in the world, and very important information, like a last minute prediction for an occultation observation. We have a last minute changing in our program. Please read the program, what is present on the web page since midnight. This is the last minute prediction. The prediction from yesterday afternoon is not longer valid. This is typical last minute occultation astronomy, last minute symposium policy. So, and for the people in the world with their computer sitting at home, have not such a long journey and can make a break, can make what they want, can wear what they want. I have a special question or special information. We have a donate button on the web page. If you want, you have the possibility to spend a little bit of money to IOTA ES to have the next ESOP also present in the world for everybody. That's my words. Three thanks. Let's go ahead.
Thank you, Konrad, for your very nice words. Good morning, everybody. I also want to thank IOTA ES for considering Granada to host this meeting. I'm very happy that we finally made it, and also I want to thank IAA, my home institution, the Instituto de Astrofísica de Andalucía, for providing the resources and everything to make this possible. The resources and everything have been provided at no cost, and trying to keep the registration fee as low as possible. This has been a challenge, especially nowadays with increasing prices for everything. But well, we've done some things ourselves, like for instance, last night catering was done by ourselves. But fortunately, the coffee breaks and everything will be done by professionals. So I also want to thank the Amateur Astronomy Society here in Granada. They have also provided people and person power and support. And also I want to thank the Astronomical Association of Sabadell in Spain too, because they also provided very valuable help for some steps in the organization. I also want to thank especially Mike, Credlow, and Pablo, because they've done a lot of hard work to come to this point now. So, and I also want to thank all the participants, as Konrad already did. I'm very happy to have all of you here, and I hope you will enjoy this meeting, enjoy Granada. Sorry about the weather, it's too hot. We tried to do this in September because we know in September the temperatures are usually better, but it's been a horrible summer and we're still suffering hot. So sorry about that. We could not do anything about that. And well, I think Pablo will have a few words regarding the logistics now. And also, I think Mike has a few things to say.
Ah, right. Okay.
Okay. Thank you very much. I don't know what more to say. Welcome to Granada. And some organizational aspects. We, the organizing committee, we have in our batch 2 red bands. Please, if you need something, if you don't understand something, ask us. Don't hesitate to ask. Also, well, I think for the lunch, don't worry. I think we have distributed a map with different places where you can lunch. But from the organization, we will go together. So I think at the end there will not be problem because we will go with you, and then we distribute in different places to lunch. One important thing that is this social dinner tonight. Okay. Yes. This is the list of people that selected this social dinner. If you are not in this list and won't attend the dinner, please say as soon as possible. In the registration desk, they have this list, because when you register, you have the opportunity to select this dinner. Well, I booked for the dinner in August, and well, I don't know. Perhaps we can take maybe 3, 4, 5 more people, but of course, no 10 or 20 more people. But if you are not in this list, please ask in the registration desk to take note.
I missed my wife. +1.
+1.
Yeah.
Yes.
First correction. There's no +1.
Ah, okay. No, yes. There's +1. No.
Oh, I see it for Mike. Oh,
Yes.
I mistake.
Okay. This, I think this is fine. Okay, and another thing. Oh, Rene, there was another slide. No. In the PDF I sent you, there was two pages. Well, in any case, you all have this instruction of how to reach the restaurant, but the idea is to meet everybody. If you want, you can go by taxi. That I think is the easy way to go to the restaurant. But the funny way is go together. I think so. So we will meet at 20 this evening together in Plaza Nueva. Plaza Nueva is a square, a very famous square in Granada, in the fountain there, and we will join together. We will go together to the restaurant, and I think that's all. Well, also some remind for the people that will attend this Monday and Tuesday special activities. Please, I think people has to pay, Mike, for the Calaralto visit. If I don't remember, but it's 50 euros per person.
The tour for the Calaralto is 50 euros.
Mm-hmm.
And for the Alhambra visit, just for the Alhambra, where we buy the ticket, 30 euros per person.
Okay. And for the Parque de las Ciencias, that is Tuesday afternoon.
Yes.
We will go there and pay, but I don't remember exactly. I don't know if Javier. 14 euros.
Yeah.
Okay. But this is not needed to pay here. You will pay when you go there.
Maybe I can add one word. We changed it a little bit because some people want to leave earlier. So it's on Tuesday. It's not one big tour where you have to pay everything. So those people which have indicated that they want to go Alhambra, they were booked, and then we go together. Monica and Javier are with you. We are going then for lunch and to the park. But and there you pay your ticket on your own, because there are different packages. You can go over to the planetarium, So we left that open to your decision. There was no need to pre-buy the tickets because they are not so limited like Alhambra, but we had to do this weeks ago, otherwise you wouldn't get a ticket. So we split this a little bit. It's not one package for the Tuesday. It's just Alhambra, and where you have to pay it back to me because I have bought everything. And just for your information, because initially we wanted to make one big package, but that's not really reasonable.
Another thing that I saw this morning, the weather forecast for Thursday is rain, so they take that into account. And I think no more things from myself. I don't know if I forget something. Yes. Well, Rene, who is the person in charge of the Zoom transmission, is going to say something about the rules and how to ask these kind of things.
No, I will use, this one. Okay, thank you for coming. I'm in charge in the meeting, the presentations, and the Zoom. As you can see, we have problems. That is normal. So it's not easy to have this kind of hybrid presentations with the persons here and the persons on Zoom and also live streaming. So the idea, the main idea is that the speaker will use this microphone, this one that I have. The person can use on the head or on the neck, is the same, right? But for the talk, use this one. Then we have the discussion. The discussion is with questions all around the room and also can be on Zoom. So for the discussion, we will use this mic here. I will change the microphone from this to this only on the discussion. So the person that is talking, please stay over here. That is okay for this mic. And the person in the room that want to ask something, please approach here or there. It's not necessary to come really close, but over here, over there is fine. And the persons on Zoom, just raise your hand and we will make the audio available so you can ask directly from there. You want to tell something about this map, or it's fine?
No, I think it's fine. If
So,
you have any doubt about the map, please ask me or any member of the organization.
we're ready.
Okay. Great. So,
So where should I go?
Is it possible to switch off this every time the command comes in? You have this ding dong, ding dong.
All right.
It's a little bit,
Yeah.
if the people are talking.
Yes.
So
Which microphone I have to use, or do you use
As well.
Okay. Good one. Hello, 1, 2, 3. Nobody hears me? Yes, me?
Yes.
1, 2, 3. Yeah.
Yeah, you can.
Okay. So welcome from my side as well. I have the pleasure to be the chair of the first session, and at least if you have the printed program, you see in parentheses after the title there are some numbers, for example 15 plus 5. So what we usually did is, if the people asked for 15 minutes talk time, we usually add +5 is +5 minutes Q&A, question and answers, except for example the discussion. If it's a point like discussion 40 minutes, there's no extra time. So what we will do, we will indicate the talkers 5 minutes ago or 3 minutes before their usual the normal talking time will end. We will give a sign that's that 5 minutes are left, and then we have, as I said, 5 minutes for questions or just to change the talker and so on, so that we don't get too much in trouble with the time. Okay, this is the latest program. It's also that's a PDF version, the printed version. We have also online on the website. I hope they are synchronized. I did it this night. Many thanks to Monica, helped a lot for the program. It's not so easy to make changes because there are some constraints where the people can talk or not. And another point. Please look into the abstracts book. I just learned that one abstract is missing. I'm very sorry for that. The problem was that behind this ESOP email address, it was only forwarded to my address and not to the whole LOC. So there was no 4 eyes verification of all this stuff. So I missed this email, and I will correct this at least at the online version, at the PDF. Maybe we can print it again. So if somebody is missing the abstract, his abstract or her abstract, please tell us so that we can change it. I'm sorry for that happened. So, okay, let's start with the session. The session we will start now is observations and results. And as Konrad already told us, last minute predictions, last minute changes, and there's also a last minute change, a very recent one, a change of the change. We will switch for some reasons, Bruno Sicardi will explain. We will switch the last two talks in this session. Bruno Sicardi and Pablo Santos Sanz, they will switch. This has some reason. I think Bruno will explain you why we put his talk directly before the coffee break. There's something to do with the information embargo. Okay, so I like to go to the first talk. It's by Jose Luis Ortiz, and he will talk about some results from occultations by TNOs and centaurs and prospects for the future. Your talking comes 20 minutes plus 5. Thank you very much, and the word is yours.
Good morning, everybody. Good morning again. Well, okay. Well, in our group here in Granada, at IAA, we have been working on the physical characterization of Trans-Neptunian objects, TNOs, and related bodies for many years. And because one of the key techniques to study solar system bodies is through stellar occultations, we teamed together with the Paris Observatory Group and the Brazilian team to collaborate in this topic for TNOs, which gave rise to the currently called Lucky Star collaboration. In this talk, I will summarize some of the highlights and the main results that we have achieved in so far in this within the context of the Lucky Star collaboration. Unfortunately, another very last minute change. In 20 minutes, I will not have time to address the issue of prospect for the future. And so we'll leave this for the discussion or for the roundtable discussion on Sunday. It is important to emphasize that predicting and observing stellar occultations by TNOs is very difficult because the angular diameters of TNOs are very small, of the order of 30 milliarc seconds for the largest TNOs, and around 10 milliarc seconds for the great majority of the known TNOs. So we need to know the position of the TNOs with that accuracy, at least that accuracy, and also the star positions, we need to know them with that accuracy. Fortunately, the accuracy for the positions of the stars is not an issue anymore because we know them very well, very accurately due to the Gaia space mission. But for TNOs, we do not know their positions with the needed accuracy. In the slide, you can see the angular diameters in a sketch of a few TNOs in comparison with the angular diameter of Pluto and Titan to illustrate the difficulty. And I'm also showing that an euro coin seen at 140 kilometers has the same angular diameter as the dwarf planet Eris. For instance, this is just to give an idea of how accurate we need to be. Well, nearly 200 occultations by TNOs have been recorded since we started in 2009, although most of them were single chord, which means that they have been observed only from one single site, and therefore we cannot obtain much information from a single site. But also a number of the detected occultations were two chord, which also offer limited information because in general the projected shapes are elliptical, and ellipses cannot be fit with two chords because this is a degenerate mathematical problem. So if we know that the object is spherical or almost spherical, as is the case of Eris, which I'm showing in the slide, we can indeed obtain important information with just two chords. In the slide, I'm showing the first highlight of the collaboration back in 2010, which was the stellar occultation by the dwarf planet Eris that we detected from San Pedro de Atacama in Chile and also from La Silla in Chile, giving rise to the two chords that you can see in red in the plot. In the left, you can see the occultation light curves, two light curves from two telescopes in San Pedro de Atacama, and one which we operate, one of which we operate remotely from Granada, and also the light curve from La Silla is from another remotely operated telescope. It was a TRAPPIST, the famous TRAPPIST that later discovered the famous TRAPPIST exoplanetary system. Well, the diameter of Eris turned out to be slightly smaller than that of Pluto, whereas at that time it was believed that Eris was larger than Pluto. We showed in the occultation that it was not. The reason was its extremely high albedo, which we found to be in 96%. The geometric albedo was 96%. We found no atmosphere at all, and we suspect that this is because the atmosphere of Eris is frozen and currently is frozen, so there are fresh ice on the surface, which explains the high albedo. And also we expect that in the future, when Eris comes closer to the sun, it will sublimate the ices, and then an atmosphere may appear. This was published in Nature, in a Nature paper in 2011. And also another relevant occultation was that caused by the dwarf planet Makemake in 2011. Oops. Well, some parts are not shown anyway. This was also published in Nature, not much later than the Eris publication. In this case, we had 7 positive chords, 7 positive detections from 5 different observatories, which gave rise to the chords that you see in color in the slide. In this case, the star was that was occulted was fainter than Makemake itself, so that is the reason that the drops in the light curves did not go to 0. But fortunately, we could use very powerful telescope at ESO in Chile. In fact, the largest telescopes in ESO, and we could determine with good accuracy the size and geometric albedo of these dwarf planets, which turned out to be midway between that of Pluto and that of Eris, which would be compatible with the existence of a local atmosphere. Besides, some of the occultation light curves showed potential hints for a central flash that might be caused by a local atmosphere, but this is not confirmed. If confirmed, it would be the first Trans-Neptunian object other than Pluto with an atmosphere. Another highlight was the observation of Quaoar occultation in May the 4th, 2011. But since Bruno is going to talk about Quaoar in depth, I will skip this, but it was the first time that we detected an occultation by also a large TNO. And from that time to now, we have detected several other occultations by Quaoar, and Bruno will talk about that. So another highlight, and possibly one of the main breakthroughs, was related to the occultation by the centaur Chariklo, which is probably the largest known centaur, but still with the size of only 300 kilometers or so. So it's not a big object. It's the biggest of the centaurs, but not a very big object of the small body population. This occultation was on June 3rd, 2013, and resulted in a considerable surprise because we discovered a ring system around this small body. This was the first time that a ring system was discovered in an object that is not a planet. Centaurs are small objects that reside between Neptune and Jupiter, and are thought to come from the Trans-Neptunian region. And they are becoming short period comets. They are in the process of becoming short period comets through the gravitational interaction with Neptune and the largest and the large and the giant planets. The best light curve corresponding to these observations is shown in the slide. And here you can see two rapid drops and sharp drops of brightness before and after the occultation of the main body. This was from La Silla, and from other observatories, similar events were detected, although less pronounced, because the quality and the temporal resolution of this La Silla data was very good. So I'm showing the best result. These brief events were produced by two narrow and dense rings around the body. When we first saw the results, we were internally debating whether these events could be due to cometary jets, because some centers have shown cometary activity in the past, but after some internal debate and careful study, the only possibility was a ring. The secondary drops are all in the ellipse, in an ellipse around Chariklo, as you can see here. The final results is what you see here. The green segments correspond to the detections of the positive detections projected in the plane of the sky, and the red segments indicate non-detections because the CCD cameras were being read out at that time. The observations imply two narrow and dense rings of 390 and 400 kilometers from the main body, separated by around 9 kilometers in width. And the diameter of Chariklo is around 250 kilometers. Besides the change in the aspect angle of the rings, in many years could explain the strange photometric behavior of Chariklo in 2 decades. Between 2014 and 2017, we recorded several interesting results, but I highlight here the occultation by the dwarf planet Haumea. The research was achieved through a very large international collaboration involving 54 institutions in Europe. At that time, it was the best observed stellar occultation by a TNO other than Pluto. But since then, we have been achieving better and better results in terms of quartz, as you will see. But this was yet another paper of the Lucky Star collaboration published in Nature, 4 in 6 years, which is very remarkable. Here I show 11 light curves of the event. Given that the occulted star was fainter than Haumea itself, the brightness drops did not go to 0, the same as in the Makemake event. And in this plot, I'm not showing the detections from Cherny-Vry, the observatory, the Cherny-Vry observatory, because it had very poor signal to noise due to the use of the drift scan technique, and the results were not really usable. Here we can see the ring resulting from the occultation. In red, we show the observatories from which the detection was obtained. In red, these red segments, that the color is reversed with respect to Chariklo. The red segments correspond to the integration time projected in the plane of the sky. As can be seen, they are all fit by an ellipse that corresponds to the dense ring. Its radius is about 2,287 kilometers, and at that distance is where the 3-to-1 spin-orbit resonance is expected for Haumea. This means that that a ring particle orbits around Haumea in 3 times the period of Haumea rotation. We suspect that the ring is confined in this resonance, probably because of stability reasons. The width of the ring is 70 kilometers, and in this case, the reflectivity of the ring is much smaller than that of Haumea. And the reflectivity is similar to the rings of Chariklo and those of Uranus. So we found that not only the centers, but also the TNOs can host rings, and hence we can discard that cometary activity could have something to do with the formation or generation of rings. So we think there are other more likely processes. But also we obtain interesting results on the body itself, not only the discovery of the ring, because we have rotational light curves of Haumea that clearly indicate that it is triaxial. It's a triaxial ellipsoid in shape. We could derive its shape and the orientation of the spin axis using the light curve information. This is an example of a light curve taken 2 days after the occultation. And it turns out that the long axis of Haumea is 2,322 kilometers long, which is similar to Pluto, to Pluto's size. The other axes are smaller, and the equivalent diameter in terms of equivalent volume is close to 1,600 kilometers. This was larger than previously thought, and the geometric albedo was smaller than previously thought. Well,
I mean, its surface was less reflected, and the density was also considerably smaller than thought before, and it was much more in line with that of Pluto. Well, the three-dimensional shape is not consistent with hydrostatic equilibrium for a homogeneous body of rotating at 3.92 hours. And an explanation for this could be a differentiated body with a dense rocky core and a lighter ice crust. But we still have some doubts that there might be some internal cohesion or, sorry. That could be playing a role. Some researchers are now modeling of the interiors using hydrostatic equilibrium to try to explain all the details of Haumea, but still some progress has to be made to be sure if hydrostatic equilibrium can explain everything or not. Well, soon after the big success of Haumea, we had another big success with the TNO named 2002 T302 because we obtained 12 positive chords and 2 negative ones close to the body. Around 55 telescopes participated in the campaign. We did not detect a global atmosphere or a ring, but there may be a satellite around this body, not detected in the occultation, as we will see in the last slides. Well, in 2019, we also detected an occultation with 12 positive chords. This time the TNO was 2003 VS2. The results have been recently published by Monica Varalubiano. Combining the results with the rotational light curves, we have been able to determine the three-dimensional shape. 2003 VS2 is large enough so that the interior pressure can overcome the material strength, and then it should be in hydrostatic equilibrium. But the shape we determined is not compatible with hydrostatic equilibrium for a homogeneous body. In the plot, we show the observed and the theoretical axial ratios for a body in hydrostatic equilibrium versus density, given the known rotation period of 3002 of VS2, and the ratio of axis BC is not compatible with the theoretical one. The reason may be that the material inside VS2 does not behave like a fluid, because the object is perhaps too small to have differentiated. In this case, radioactive decay is probably not enough to heat and melt the interior sufficiently to make a significant differentiation. For Huya, we have nice results, but I will skip this because Pablo will be talking about Huya. We also have an article in preparation regarding 2002 KX14 with 9 positive detections that allowed the determination of accurate size and shape. No rings and no atmosphere has been found either, but again, narrower ones cannot be discarded. Also, in preparation by Flavia Rommel is a paper on several occultations by 2002 MS4, including the one on August 8th, 2022, which was the best occultation by a TNO ever, the best observed ever. There were more than 50 positive detections, and we can see a very large topographic feature in the northeast of the body, which is something remarkable. We're putting together a nice paper with all the information we have on this body. Unfortunately, we don't have a good rotational light curve for this object. because it moves in a very dense stellar field and it has a very low amplitude of variability. So we're still trying to come up with a good three-dimensional shape. Also, there have been interesting occultations by the large TNO named Ixion. Here I show one. This is work in preparation by Giselle Silic and Felipe Braga Rivas. Another remarkable occultation with 29 chords was by 2002 TC302 in November last year. From a preliminary analysis, the size is completely consistent with that determined in 2020 in the 2020 paper that I showed, but the orientation of the ellipse is not identical. You can see here the different orientations of the ellipse. The change in the position angle of the ellipse implies that the object cannot be of Maclaurin type, and it must be triaxial, probably with its spin not far from the line of sight, with its spin axis not far from the line of sight. This is work in preparation by Mike. We have a similar problem here as with 2002 MS4 because the rotation period of this object is not well known, and also the amplitude of variability is very small, so we're trying to reconstruct the three-dimensional shape, but we have some difficulties. An interesting point is to compare the diameters obtained from thermal imaging using now the defunct Herschel and Spitz telescopes with the much more accurate diameters and shapes obtained through stellar occultations. We can then improve the thermal models, for instance, to improve our knowledge on some surface properties such as thermal inertia and roughness of the surfaces. We have 180 TNOs observed through the TNOs Are Cool project. So we have Herschel and Spitzer data for 180 objects. But the comparison of these diameters has to be made very carefully, taking into account many details, rotational phases, many aspects, and using occultations with more than 3 chords so that we have accurate shapes. This comparison can be used also to spot interesting anomalies, as I will show in a minute. Here I show the diameters from occultations versus the effective diameters from thermal models for a sample of 11 bodies. If the agreement was perfect, all the points should align with the straight line, but but the best fit is in dashed line, and we can see that there is a slight underestimation of the diameters from the thermal technique. The underestimation in the case of Haumea is very large, and it's explained because Haumea is extremely elongated. Anyway, in all cases, the thermal models underestimate the diameters except for the 2 points highlighted in yellow, which corresponds to TC302 and MS4. They are outside their error bars. And the anomalies mean that something wrong with what we know or what we assume, or there are systematic errors. One possibility that makes sense is that 2002 TC302 could have a satellite of around at a distance of 1,000 kilometers or so. Since I'm running out of time, or I ran out of time, I will skip this. I just want to emphasize that this anomaly might indicate the presence of a satellite, although other possibilities are being considered. And okay, thanks, and sorry for being late.
So do I have to go to this microphone now?
Yes.
Okay, so thank you very much, Jose Luis, for this very interesting talk and overview about all these very nice results of the last years and the ongoing work. So we are running a little bit out of time, but I think it was a very interesting talk, and so I I want to give the opportunity that we have some Q&A. So, are there any questions here in the auditorium? Yes. I think
Maybe you can give a short outlook for the future, especially for predictions, what we are interested on. Will Lucky Star on the webpage provide for the next year's predictions, or what's happened there?
Yeah, the idea is that the Lucky Star collaboration will still be producing predictions. The thing is, the Lucky Star funds, we ran out of funds, as Bruno probably will say. He is the one who got the funds initially. But I think the collaboration is strong enough that we will still be providing predictions, and also we plan to make predictions of fainter and fainter objects because the sample that we originally used can now be improved. So yeah, there are plans on that. Yeah.
Okay, thank you.
so. Other questions here in the auditorium to Jose Luis? No? Yes, I think just come to
Approach here.
Yeah, so that for the Zoom.
The presentation is not there, but I have a question about the 2002 TC302 event for which we had all the light curves. Considering there was no atmosphere detected, but I saw that on 3 or 4 light curves there were small spikes in the middle, which could suggest an atmosphere. But I was just wondering if you consider that this was not large enough to be above noise level.
Yeah, we analyzed the noise level, and none of the spikes were at more than 3 sigma from the noise. But we can still work to improve the noise in the bottom of the light curve, because we now have techniques to improve that just that part of the occultation, and maybe something can pop up. We don't know yet.
Yeah.
You showed the results of the TNOs with the centaurs with the ring systems around, but that none of them so far had the atmosphere detected. And my question is, if an object is large enough to have a ring system, should we expect it to have an atmosphere? Or because of the distance, you said that it might be that it's frozen, but should we expect that the object has a strong enough gravity field that it has an atmosphere to be detected?
Well, we think that in order to retain an atmosphere, the object has to be very, very big, at least 1,000 kilometers long. So there are very few good candidates for that, at least to have a global atmosphere. Local atmospheres are more likely, in the sense that if you have a patch of ice on the surface of a body, and this ice is made of volatiles, enough volatile, they may sublimate at certain conditions and generate a local atmosphere. That is possible for more objects, but essentially we need very large ones.
Okay, thank you. Other questions here in the room? Zoom, I suppose that they should put it on the chat, and maybe Jose Luis can on the online. So we have to switch to the next talker. That is, as I explained, that will be Pablo, who's giving his talk now. And Pablo Santos Sanz will talk about the stellar applications on the Trans-Neptunian object 38628 Huya. And the talk time is 15 minutes, that's 5 for Q&As. The floor is yours. Oh, we need your slides. Okay.
It's possible to switch on this
in order to have. ¿Sí?
Y aquí no se está viendo, eso es un problema.
Ya has tocado.
There's no problem if you 15 minutes late or something.
No, I ask people of the coffee break and they say it's fine. I say we are 10 minutes, but I think it's not problem. Why is the color? ¿Por qué se ve verde? Okay. No. Okay. You can put outside of the window. No. Oh. Okay. Okay, good morning again, people here and people connected via Zoom. I have switched on this microphone in order that people here in the room also can hear me. I'm going to talk about the physical properties of the Trans-Neptunian object UJA that we derive using a multi-core stellar occultation. These results were published in a paper this year. Oh. It's not. Okay. Thank you, Rene. Oh, this is the star at the center of the image that was occulted. We predicted this stellar occultation of 11 magnitude star by UJA, and then we refined the prediction using a dedicated astrometric campaigns at different observatories in Spain and in Brazil, starting January, March 2019, to a few days prior to the occultation date. These are the details of the stars with the diameter of the star in milliards seconds, also in kilometers, coordinates, and the velocity of the shadow that was around 8 kilometers per second. This is our last minute prediction. Oh, I don't know. No, but here I can see in the screen. I don't know what happened with. Huh? We are. Yes. No, but in the screen of the laptop is visible. I don't know. Okay, perhaps it's a problem of the projector. Well, we use astrometry acquired a few days prior to the occultation with a 1.5 meter at Sierra Nevada. And then we obtain a reliable prediction. And the favorable shadow path was for different countries in West Europe. Then we contacted people in different parts of Europe, including non-professional astronomers. And at the end, around 50 observatories participated. And from 21 of them, we detected the occultation. Oh, okay. Okay, I'm sorry. I can see here the map perfectly, but This is the final shadow path with the positive in here in the laptop screen are in green. These are observatories with bad weather, and with the negative. I don't know why this is not working. Well, this is the best ever stellar occultation published, because Jose Luis said that there we have more occultation with more cores, but up to date is the best stellar occultation published by a TNO in terms of the number of cores, excluding Pluto, 2002 MS4. That was detected in August 2020. Okay, I can see this. Okay, these are the light curves of the occultation, including different observatories. Here, for instance, you can see that there was problem with the ingress. Here, there was a problem with the camera, and also this observatory, this light curve in red, was a problem with the teaming. Finally, we just used to confirm the shape, the final shape, bidimensional shape of the feet. This is the UJA projected shape that we obtained from the different occultation, from the different light curve. This is the instantaneous elliptical limb fit. You can see that it's around 400 kilometers by 380 kilometers. We also derived this axis ratio. And interestingly, that the equivalent diameter in area is 411 kilometers. That is slightly bigger than the radiometric. I mean, for radiometric, the thermal based diameter derived, that is around 406 kilometers. Also, we obtained the geometric albedo that is slightly smaller, but very close to the radiometric albedo again. We also obtained data to refine the rotational light curve, and we obtained this period as the preferred period. Also, this very small amplitude that is a bit larger than the amplitude that we had from the literature. This is the possible period, and we finally choose this as the more probably period for UJA. Using this information and the occultation, using the rotational period and the occultation, we can derive a different 3D shape for UJA. If UJA is a McLaurin spheroid, the expected density for a TNO of this size is around 800 kilograms per cubic meter. And a McLaurin rotating with this rotational period and with this density will have this axis ratio. This ratio is larger than the ratio that we obtain from the occultation. This means that the aspect angle of the object should be very small. This means a small probability. From this, we can obtain a possible 3D shape. That is this one. Of course, as is a McLaurin, we have A and B with the same value. And for the other possible uncertain rotation period, I mean this other two rotational period possible, 5.2 and 4.3. We obtain aspect angle smaller than 32, which is even more unlikely. Okay, if the object is a triaxial, the shape of the object is a triaxial ellipsoid, the minimum density for this rotational period is 860 kilogram per cubic meter. And the aspect angle compatible with the axis ratio that we obtain from the occultation and with the amplitude of the light curve span from 31 to 43 degrees. And for this aspect angle, we have a family of Jacobi solutions that well, if we use the other rotation periods, 5.2 and 4.3, the density that we need is very large, which is also very, very unlikely. Also, of course, an alternative 3D shape solution to McLaurin or to the Jacobi shapes invokes a non-hydrostatic equilibrium shapes using granular media or differentiation, which would need, okay. What about rings or satellites? We did not detect secondary drops below the 3 sigma level of noise in the positive or negative occultation light curve related with possible rings or the satellite of Uya. I forget to say that Uya has a known satellite. At the end, no dense rings similar to those detected around Haumea were detected. However, we can constrain the rings, and we can say that very narrow or optically thin rings cannot be totally discarded. Also, we search using our best quality occultation light curve. We search for a possible atmosphere. No atmosphere is detected, but again, we can derive an upper limit for a putative atmosphere, a putative Pluto-like atmosphere of this upper limit is of around 10 nanobars. And this is my last slide. This is, as I said, the best ever stellar occultation by a TNO in terms of number of cores that have been published. We obtain an accurate equivalent diameter and albedo. We propose possible 3D shapes. We do not detect any hint of rings or this. We didn't detect the satellite. And also we place constraint on a possible Uya atmosphere using the best quality occultation light curve. And I think, yes, this is my last slide. Thank you very much.
Thank you very much, Pablo, for your talk. So we have a couple of minutes for questions and answers. So any question here in the room to Pablo? Konrad?
I saw you had some observation from Romania.
Yes.
How did you inform them? How was the information flow?
Okay,
Normal
yes.
information flow, we don't get any response from Romania.
Yes, I have a trick. I have contact with a professional astronomer there that he's in contact with many amateur astronomers, non-professional astronomers there, and he motivated them to observe. If you want, because I know that there are not many people from Romania in IOTA S. So if you want, I can provide you this contact with this professional, and perhaps you can contact all this amateur. I think they should be very interested in joining IOTA S.
Yeah, thank you.
So welcome.
Okay. Another question here?
Just a short comment to Konrad.
Yeah.
You were previously asking me about contacts in Ukraine, but I actually have more contacts in Romania with amateurs. Probably it's like related. There's more people who just not in the network.
Okay.
Okay. I can follow up this.
Okay, thank you. So any other questions here in the room to Pablo? No? Question to René? Any questions from
No.
the Zoom?
From Zoom.
Okay, thank you. So thanks again to Pablo for that talk. So we will switch now, and as far as I know, because the next talk by Bruno Sicali, there will some information embargo. So if I'm correctly informed, we have to we cannot stream this talk to the publicity. So we have to stop at this point the Zoom as well.
No,
No,
only YouTube.
okay, we have to stop the streaming on YouTube, and the Zoom session will remain.
Yeah, so for the YouTube people, there are
9 persons there. Please move to Zoom if you have the link, because we cannot put this on YouTube.
Okay.
We will resume on YouTube after the coffee break.
Okay, fine. And I think Bruno will also give you some information. I don't know if you are taking pictures or